Welcome to the Deep Dive. We dig into complex stuff and pull out the most surprising bits of knowledge for you. Today, we're looking at your electric car, or maybe the one you're thinking about buying. And the idea is it's not just a car, right? Honestly, that EV in your driveway, it's secretly this amazing Swiss Army knife for energy. It's way more than transport. It's like a power plant on wheels.
It really is. And that's our mission today, to explore the whole ecosystem around EV batteries. Specifically, what they do when the car's parked, which is most of the time, let's be honest. We're diving into V2X, vehicle to everything. We'll look at the surprising usefulness of V2L, vehicle to load. And then there's this huge, often overlooked economic value in retired batteries, their second life.
Yeah, we're going beyond just, plugging it into charge. We're talking about your car potentially making you money or being a lifeline in a blackout.
Exactly. And this deep dive, it's really about putting it all in context. We're moving, and pretty quickly, from the old grid, big power plants, one-way flow to something much more decentralized, dynamic. And in this new setup, your EV isn't just using energy, it's a key player, a flexible asset. So we'll have some practical tips, maybe for your next camping trip, but also the big picture stuff, how the future grid might actually work.
Okay, let's start practical then. The power trip, literally. V2L vehicle to load. We found this great story, a real-world test with a BYD Dolphin. The owner basically ditched all the old camping gear, so they traded an indestructible 1956 Primus stove. You know the kind, probably smells like kerosene, for a sleek, modern induction cooker. All electric.
Yeah, quite the upgrade. And much cleaner camping, definitely. The key thing from that test was how V2L just solves common outdoor problems. They were camping right on the coast, apparently dealing with this gnarly 30-knot southerly wind. Anyone who's tried to cook outside knows wind like that makes a gas stove almost useless.
Oh, totally. Nightmare.
But the induction cooker, powered straight from the car. It was, and I love this quote, oblivious to wind.
Oblivious to wind. That's brilliant. Real next-level convenience for camping. And they said even a double-burner induction hob was drawing well under the car's 2.2 kilowatt V2L limit, so they could run that, a fridge, and basically, quote, light up our camp like a mine site. That sounds amazing.
It does sound pretty good. But, like with any new tech, there were some lessons learned, a few quirks, stuff that's actually really important if you're planning on using V2L.
Okay, lay it on us. What are the pitfalls? The gotchas?
Right, first up, the difference between the car's outlets. The proper V2L system, the one giving that solid 2.2 kilowatts through the main power outlets, that worked even when the car was technically off.
Okay, that's what you'd expect.
Their standard 12-volt outlet, the little cigarette lighter socket they use for their small camping fridge, that only had power when the car was actually on, like ignition on, systems running.
Ah, okay, I see where this is going. So to keep the fridge cold overnight?
They had to leave the car on, which naturally meant the daytime running lights stayed on all night.
Oh, dear. I can picture it now.
Yep. Cue multiple visits the next morning from well-meaning old codgers, as they put it, all warning them they'd flatten their battery, leaving the lights on. None of them twigged it was an EV, basically a giant battery on wheels.
That's hilarious. But okay, leaving the car on all night.
Yeah.
That had a cost, right? A real energy cost we need to flag for you listening.
It absolutely did. That was the big downside. Leaving the car on meant a pretty significant parasitic draw from the car's own systems. They measured it about 6 kilowatt hours used overnight.
6 kilowatt hours, just to keep the car's brain awake.
Pretty much. Way more than the fridge and a few lights actually needed. It was the car's main computer, the displays, all that stuff just idling.
Wow, 6 kilowatt hours. That's like, what, 20, 25 miles of range in the typical EV? Just gone, overnight, all parked.
Exactly. A noticeable chunk of your battery vanished just keeping the systems humming. So the next night, they changed tactics, turned the car fully off, ran the fridge from an auxiliary battery that they charged using the V2L outlets during the day, and the drain on the main EV battery dropped way down, under 2 kilowatt hours.
Okay, that's the key takeaway then. Huge difference. You absolutely need to check if your EV keeps power flowing to the 12V socket or even the V2L outlets when it's properly turned off. Because if it doesn't, you're either running things off a separate battery like they did, or you're potentially losing 6 kilowatt hours a night just to parasitic drain. That adds up.
Excellent summary. Know your car's quirks.
Okay, so we saw how the EV's own systems created that 6 kilowatt headache while camping. Now let's flip it. Let's talk about how that same smarts, that computing power, could become the brain for like a whole energy solution. This is V2X, right? V equal to everything. V12 is just one small piece.
That's right. V2X is the umbrella term. It's the concept that really unlocks the EV as an energy asset, not just a user. It basically covers three main ideas, all using the battery's ability to send power out, not just take it in. Bidirectional capability.
Okay, break them down. Let's start with the one that feels most immediate.
That'd be V2H. Vehicle to home. Think of it as the ultimate home backup. Your EV basically acts like a giant home battery during a power cut. Take something like the Ford F-150 Lightning. The figures suggest it can power an average home for 3 days, maybe even up to 10 days, depending on how much you use. And if you've got solar panels, you store that daytime energy in the car, use it at night. Big potential savings on your electricity bill, too, even when the grid is working.
Okay, home backup. Makes sense. Then you mentioned zooming out.
Right, V2G, vehicle to grid. This is where your car helps the bigger picture, the actual electricity grid. It helps stabilize things by feeding power back into the grid when demand suddenly spikes. Think a heat wave, everyone cranks the AC at 5 p.m.
So instead of firing up extra power plants,
Exactly. It reduces the need for those really inefficient, dirty, and expensive peaker plants, usually gas, sometimes coal. They just sit there until needed, then fire up quickly. V2G means a whole network of parked EVs could potentially handle those peaks instead. Cleaner, cheaper, and this is where you, the listener, might eventually earn some money back through what they call demand response programs, selling power back when the grid needs it most.
okay, earning money sounds good, but hang on. Doesn't all this charging and discharging, sending power back and forth, doesn't that hammer the battery? Wear it out faster? Like, is the few quid you might earn worth potentially knocking value off your car long term?
That's a really important question, and the research so far suggests the impact is actually pretty minimal, especially if it's managed smartly. The systems are designed to operate within the battery's optimal charging window, avoiding really deep discharges or staying at 100% too long. Plus, you have to weigh it against the bigger benefits, less pollution, a more stable grid, avoiding massive investment in new peaker plants. The societal value is huge. But you're right, tracking battery health is critical, which leads perfectly into why the second life market we'll discuss later is so vital.
Fair point. Okay, before we get there, you mentioned a third one, V2V.
Ah, yes, V2V, vehicle to vehicle. This one's mostly about safety, for now at least. Cars talking to each other directly, sharing real-time data, I'm braking hard, ice patch ahead, that kind of thing. Collision warnings, smoother traffic flow. The U.S. Road Safety Agency, NHTSA, estimated V2V could cut crashes by at least 13%, so it's potentially life-saving tech.
Okay, safety, got it. Let's swing back to V2H for a sec, vehicle to home and the solar angle, because the sources mentioned a really key safety point about blackouts.
Oh, absolutely critical. Normally, your rooftop solar panels have to shut down instantly if the main grid goes down. It's called anti-islanding. It's a safety rule. Stops your panels accidentally sending power back onto the grid lines and potentially electrocuting line workers trying to fix the fault. Makes sense.
Right. So solar's useless in a blackout, usually.
Usually, but a V2H-capable EV changes the game. It acts as the local grid anchor. It provides the stable voltage and frequency needed to trick the solar system into thinking the grid is still there, locally at least. It essentially creates a safe, isolated microgrid for your house.
So the car becomes the mini grid controller, telling the solar panels, okay, coast is clear, keep generating.
Precisely. The EV is the brain and the buffer. And simulations show this combo, V2H plus solar, can keep a house powered for a long time, anywhere from maybe 19 hours to, get this, 600 hours, depending on the car, the solar setup, the season, your usage.
600 hours. Wow, okay.
What's also interesting is comparing plug-in hybrids, PHEVs, with pure battery EVs, BEVs, in these blackout scenarios. PHEVs have that backup gasoline engine, right? So they're less worried about the initial battery charge. A gallon of gas gives about 8.4 kilowatts of electricity via the generator. Pure EVs, the BEVs, they rely entirely on what's in the battery, plus whatever the sun provides during the outage.
That brings us to this interesting problem called spillage. Sounds messy.
It's about wasted energy. Spillage happens when your car battery hits 100% full, but your solar panels are still pumping out power because the sun's shining. That extra solar energy has nowhere to go. It just gets curtailed or spilled, wasted. This is especially an issue for PHEVs. With their smaller batteries, they fill up much faster, which raises a really important point. We need smarter control systems.
Hence,
HEMS.
home energy management systems.
10 Fs. Okay, another acronym. What's that actually do? Sounds like a fancy thermostat. It's way more than that. Think of HEMS as the conductor of your home's energy orchestra. It's looking at everything: the weather forecast, how much sun you'll get, the current charge in your car battery, your predicted energy use, maybe even electricity prices. And it makes smart decisions automatically, like, okay, battery's nearly full, sun's still high, let's turn on the washing machine now, or let's pre cool the house while energy is free. It shifts those flexible loads around to soak up that solar power, prevent spillage, and maximize how long you can run off grid or just minimize your bills. It's coordinating everything.
Right, the ultimate energy optimizer for your house and car. Very cool. Okay, we've talked about the EV charging, powering campsites, backing up homes, talking to the grid. But now this is where I think it gets really interesting, the second life economy.
Mm.
What happens when that big, expensive battery eventually degrades? When its capacity drops below, say, 70 or 80%, and it's not ideal for driving anymore? Is it just junk?
Absolutely not. That's the key. That retired battery is still incredibly valuable. It's actually highly profitable for what they call stationary storage. Think home battery systems like a Powerwall, backup for businesses, helping balance the main grid. These jobs are generally less demanding than constantly powering a moving car. Lots of power, quick bursts, recharging. Stationary use is often gentler, so a battery with, say, 77% of its original capacity might still have another decade of useful life in a different role. And this second life market is crucial. The money made from selling these used batteries helps bring down the upfront cost of new EVs. It's a huge part of the economic puzzle.
I loved how specific the sources got here. They talked about an optimal point to retire the battery from the car
Yeah.
based on economic modeling, right?
Fair.
From China.
Yeah, exactly. They crunch the numbers to find the sweet spot. When does retiring the battery maximize the total surplus of economic welfare, which is just economist jargon for getting the absolute most value out of the battery across its entire lifespan, both in the car and in its second life, and the number they landed on? The ideal remaining capacity for retirement is precisely 77%.
77%. That is incredibly specific. Why not just 75 or 80? What's magical about 77?
It's all about the trade-off. If you retire too early, say at 85%, you're throwing away perfectly good driving range and utility that you paid for. You lose value there. But if you wait too long, retired at maybe 65%, its remaining capacity is so low that its value for stationary storage is significantly reduced. It just can't do as much for as long. 77%, according to this model, is that inflection point. It balances the remaining value for driving against the potential value in its second life to give the maximum combined economic benefit.
Okay, that makes sense. It's the peak of the combined value curve. So
Yeah.
what kind of actual cash value are we talking about for one of these used 77% batteries?
Pretty significant value. The model suggested a battery retired around 80% and used in its second life down to maybe 50% capacity could be worth around 785 Chinese yuan per kilowatt hour. That translates to roughly 116 US dollars per kilowatt hour. Now put that in perspective. That's about a third of the cost of a brand new automotive grade battery, and it's often considerably cheaper than buying purpose-built new batteries for home storage.
Wow. So it's definitely not scrap metal. It's a recognized commodity with real value. How do we make sure this market actually functions smoothly, though? Seems like there could be pitfalls.
Good point. The sources propose a model they call cascade utilization. Basically, the car manufacturers would collect the used batteries when they hit that retirement threshold. They then sell them on to specialized energy storage operators, companies whose business is repurposing these batteries. But here's the really clever part, designed to build trust and manage risk. These operators should ideally lease the second life batteries to the end users, homeowners, businesses, instead of selling them outright.
Lease them. Why not just sell them? Seems simpler.
It tackles what economists call asymmetric information. It's like buying a used car, right? The seller knows its history, you don't. Was it driven gently or thrashed? Same with the battery. You, the buyer, have no real way of knowing its exact condition or remaining lifespan. That uncertainty kills the market. Leasing flips the risk. The operator, who can test and monitor the battery, guarantees its performance. If it degrades faster than expected, you just get a replacement under the lease. It gives the end user confidence.
Ah, okay. So the leasing company takes on the risk because they have the expertise to manage it. That's smart. It's like built-in quality control for the customer. So let's tie this all together. For someone thinking about buying a new EV today, what does this whole second life economy actually mean for their wallet?
It means a lot, potentially. That residual value, the profit expected from the battery's second life, is factored back into the original price of the EV. The estimates for popular Chinese EV models were that this second life value, somewhere between 24,000 and 82,000 yuan per battery, could account for anywhere from 14% up to maybe 36% of the initial purchase price of the car.
Whoa, hold on. Up to a third of the sticker price is basically covered by the future recycling value of the battery.
In essence, yes. That guaranteed future value makes the upfront cost much more competitive against traditional petrol or diesel cars. The whole EV transition kind of hinges on this circular economy working efficiently.
Okay, so getting that 77% retirement and reuse pathway right is absolutely critical.
Critically important. Which naturally brings us to policy. If we want this to work at scale, and for you, the consumer, to really benefit, a few things need to happen. We desperately need standardization: battery sizes, shapes, connections. Right now, it's a bit of a wild west, making large-scale reuse much harder than it should be. We also need transparent, reliable ways to track battery health and history, like a battery passport. And finally, maybe making that 77% capacity figure a formal warranty trigger point for replacement could really help solidify the market and lock in that value.
This has been genuinely fascinating. It completely reframes the EV. It's not just a car. It's impacting everything from your weekend camping menu to the stability of the national grid.
It's a profound shift. Every time you plug that car in, you're interacting with this emerging dynamic energy system. And just to leave you with one last thought to chew on, think about a really major long-term grid outage, like after a hurricane or something. The modeling suggests something pretty cool. If you manage your EV battery carefully, let it drain down, but not completely flat, that little bit of remaining charge can be used to black start your home solar system once the sun comes back up.
Black start the solar. You mean the solar panels need a little kick from the EV to even start working again after a total blackout?
Exactly. In a total islanded state, the solar inverter needs a stable voltage reference to synchronize and start generating. The EV battery provides that initial kick. Once the solar is running, it can power the house and recharge the EV, so you could potentially have sustainable, albeit maybe not continuous, power indefinitely, just cycling between the sun and the car battery. Your EV could literally keep the lights on, pausing only to let the sun recharge it. Perpetual energy independence, essentially, during a disaster.
That is quite something. From dodging warnings about flat batteries on a campsite to potentially restarting your home power after a catastrophe,
Yeah.
your EV is doing some heavy lifting.
The future grid is definitely decentralized, it's dynamic, and a big part of it is probably sitting on those four wheels in your driveway right now. Understanding that potential is the first step.
Well, thank you for walking us through that. This deep dive into V2X and the surprising economics of second life batteries has been eye-opening. If you found this as interesting as we did, make sure you subscribe and follow the channel. We've got plenty more fascinating topics coming up. Thanks for listening, and we'll catch you on the next deep dive.